Good morning, everyone. Assalamu alaikum. Can you all hear me, students? Can you all hear me? Can we start the class? Are you all sleepy, children? Hopefully not. Okay. So you people are awake. Right. Okay. So then let's start the work. Right. So children, today we are starting a new lesson, right? Which is an important lesson out of your grade 11 syllabus. Hopefully you know that. And the people who don't have the tune, who did not get the tune through WhatsApp, leave a message to this number in order to get it. Okay. Send a message to this number, then I will be sending you the tune. And the people who were there in the group, it got little delay to send because my device was not working yesterday and now it is all right. So it got little delay to send. Okay. Right. So today, listen very carefully. We are starting an important lesson, right? And it is a free session. You can share with your friends if anybody is in need of learning the lesson. Okay? Right. Now listen very carefully. Very carefully concentrate. Leave all your pens, book and everything. Just focus first. Okay? Right. So we are starting the third lesson, which is mixtures. Right? We are starting the lesson mixtures. Right. So all the time, children, whenever we start a lesson, I tell you why that lesson is important and how you are supposed to study. That is a usual way of the teaching, right? Usually, I tell you why you have to study the lesson. What is the most important point that you have to study, right? Usually, I tell that. So similarly, today let me tell you why you have to study the lesson mixture and how to study, right? Okay, listen now. When you talk about the lesson mixture, it falls under the category of chemistry. It falls under the category of what? Chemistry, right? So chemistry means, children, how are you supposed to study chemistry? Is it about memorizing? It is about all the way you study, like you have fully equation, only calculations? No. It is like a partially you have certain theoretical parts and certain calculation parts. So overall how you have to study? You are supposed to study by understanding the concept. Okay, by understanding the concept only you can study chemistry, right? And then children, most of the time when you take a lesson, there can be certain calculation parts and there are certain theoretical parts. What do you mean by theoretical parts? Certain places you are supposed to memorize. So remember one thing, memorize in the sense, I don't tell you to study whatever, like you have a paragraph, you don't know what is the idea, you have no idea of what is that paragraph, okay, what is said in the paragraph, but as a parrot you just keep on repeating. Not that memorizing. Not that memorizing. Memorizing means where you have to have the understanding and learning. Okay, understanding plus learning is referred to as memorizing. So understand that well. Okay, so let me tell you what is the plan to study the mixtures lesson. We are going to classify this lesson into two parts as part 1 and part 2. Part 1 session will happen today. Part 2 session will happen next week. Okay. Today in part 1 session we will be focusing on main like the basic theory parts as well as the calculation. Right? In part 2 entirely we will be studying about the calculation. Not the calculation, the theory parts. The separation techniques will be studied. Okay. So that is the plan. Are you all clear with the plan? Are you all clear with the plan? No, dear, part 2 session is not free. Like, since this is the very first start like the introductory session up to the third lesson. That is why it was kept to be as pre-session. All okay? Can we move to the lesson? Good. Right. So listen very carefully. Let's start. Okay. Now, let's decode from the heading itself. Listen very carefully. Okay. Now, you're not going to write for some time. You're going to just focus on the book. Okay. And to my words. You're going to give your attention to my words and what is written on the book. Okay. Now, when you study about mixture, first of all, children, you have to know what is a mixture. What do you call as a mixture? That idea, it is necessary, you know. What do you call as a mixture and what is a mixture? First of all, you have to know, right? So, you have to know that whatever the mixture that you take, they all are matter, right? Let's come from the basic. Let's come from the very basic idea, okay? What do you call as a matter? What is a matter, children? Can anyone tell me what do you call as a matter? Children, please don't send messages to the host, okay? Because I will not be seeing. Make sure you all the time send all your doubts or whatever the clarification you need. Send a chat to the co-host. Don't send it to the host. If you send to the host, I will not be seeing. Right? So I see some students have sent to the host. Please don't send it, children. So I did not reply yet to your question. Just send it to the co-host. Okay? Right. What do you call as a matter? Has a mass and energy is matter. Energy? No. Mass is correct, but not energy. Very good. The substance that having a mass and occupy space. Energy is two different things. Matter is the opposite of energy. Energy, they do not have a mass. At the same time, they do not occupy space. But when you talk about matter, they have a mass as well as they occupy space. Right now, when you take a lid, okay, let's assume this is how do you prove this is a matter? This has a weight. There is a mass, not a weight. There is a mass. And when I keep it, it occupies a space. So that is the idea of matter. Okay. So whatever the mixture that you take, they are supposed to be a matter. What do you mean by matter? Where they have a mass and occupy space. Okay. So, mixture is where children there is two or more components. You find two or more substance combining together, right? You don't find one substance. When you find one substance, that is not a mixture. When you have two or more components, whatever you find, the elements that you find, you call it as the components. So, how do you start the topic of mixture? How do you explain mixture, children? Mixture is a matter where two or more components are mixed. Okay, two or more components are present. Right? Then you have to understand when you find a mixture, it is not chemically combined. Okay, it is not chemically combined. There is no any sort of chemical reaction taking place. Right? They are not chemically combined each other. Right? They are chemically distinguished. Okay, they are not chemically combined. But what you can do? What you can do? You can separate them through physical methods. Okay, now you can separate it. Now, when you have a mixture, like you are using a vaporization technique, you supply heat, then the particles or the components in the mixture can be separated. We'll come to that point in a while. For now, just try to understand the basic. We'll come to that in a while. Okay, but you have to understand they can be physically separated, or they can be physical methods can be used in order to separate the components in a mixture, right? So that is the idea of what is a mixture. Listen very carefully once again, right? Mixture is a matter. You start with that. That is how you define what is a mixture. Okay? Mixture is a matter where two or more components are present. Okay? They are not chemically combined, but they can be separated by undergoing physical methods. where they can undergo physical methods and separate the components in a mixture, right? Now, for example, let's assume that you have a bag. Okay, in that bag, let's have some colors of marbles. Okay, you find red color marbles as well as blue color. Right now, let me explain the idea. Right now, this is a mixture. This is considered to be a mixture. First idea. What is that? Everything should be a matter. Okay, whatever the marble that you find in the bag, all should be what? They are matter. Why? They should have a mass and as well as they should occupy space. First idea was okay, right? You find two or more components in the bag, two or more pebbles you find it in the bag. So that is considered to be a mixture. Then you can see that the marbles, red color marble and blue color marbles are not chemically combined. They are not chemically combined, but they present together. But not chemically combined. There is a difference between, like you find it together, but they are not chemically combined. Okay. Then the last one, you can use physical methods to separate. What is a physical method? You take two bowls. Okay, you can use two bowls. You separate the red color pebbles and the blue color pebbles. You can take the red color pebbles into a different basket and the blue color pebbles into different basket. How did you separate it? How did you separate it? By undergoing a physical method. Physically, you are using your hand to separate it. That way you call as the physical method. You use a physical method to separate the components from a mixture. So this is known as mixture. Okay, this is how you define what is a mixture. Come again, listen very carefully. Mixture is a matter where you find two or more components present. It is not chemically combined, but it can be physically separated. Okay, simple idea. When you go through the board of whatever it is written here, you will be able to define what is the mixture by yourself. Listen, you're not supposed to memorize. It is not about like memorizing, like you don't know what is said, but you keep on repeating, you mug it up. No need to do such work. No need to do such work. Just study 2 hours, 2.5 hours you are being here. Just do the work and leave. Okay? Listen. Mixture is a matter. Come again. You are supposed to tell. Okay, you are supposed to tell. Mixture is a matter where you find two or more components present. It is not chemically combined, but physically can be separated. Right? Is that clear to you? Did you understand what is a mixture? Let me know, children. Did you understand the idea of what is a mixture? Everyone, you can send messages to the chat or you can unmute and speak. Right? But at the end, you have to be interactive. Either way, you can use chat or you can unmute, but you have to be interactive in the session. Right? That is a must. All okay, everyone? Good. Right. Okay. Now, children, when you study mixtures, now you know what is a mixture. Mixture is a matter and everything is there. Now you know what is a mixture. This mixture can be in two forms, right? You can find mixtures in two varieties or there is a classification in mixture. Okay? As the way you divide it, like you can consider to be in two different ways. As homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures and heterogeneous mixture. Right. So this is one of the topic that you might have studied in your previous grade. Not a very new topic, but you might have a certain knowledge about it. Okay, not a big one. And here also you don't detailedly study, just a rough idea is necessary. Right. Now, for example, let's study about this homogeneous mixture, right? So when you study about homogeneous mixture, let me take a solution of sugar. Okay, let me take the solution of sugar. Right. Now, what are the components that you can find here? What are the components you can find? One thing you can find the sugar. In the sugar solution, you find the sugar plus water. When you combine sugar and water, that becomes a solution, right? So now children, when you observe, now imagine you are having a sugar solution in front of your eyes. Okay, just imagine, right? So hopefully you have seen what is a sugar solution, right? You know what is that. Okay. Now you have it in front of your eyes. Now tell me children, can you, after the sugar dissolves into water, can you differentiate the components? Can you differentiate the components present in the homogeneous mixture or the solution? Yes or no? When you observe a sugar solution which is in front of your eyes, right? Can you differentiate the sugar particles and the water content? No, you can't. No, you can't. You can't differentiate them. Okay? So, homogeneous mixtures means children where the components cannot be observed separately. You can't identify the sugar particles present as well as the water. You can differentiate. Okay, you find some sugar crystals here and the water here. You can't differentiate it. Okay, so when you can't separate the components in a mixture, when you can't separate the components in a mixture, you call that as a homogeneous mixture. Simple way to remember homo as same. Homo means same. Wherever you hear the word homo, it is same. But that doesn't apply for Homo sapiens. Okay, don't misunderstand the concept. In that way, it doesn't appear. But like a homologous chromosome, when you have heard about homologous chromosome, that way it is same. Okay, where the chromosomes are same. Homogeneous means where the components cannot be distinguished or you can't separate the components present in the mixture. So those type of mixture you call as the homogeneous mixtures, right? So then children, what do you have to understand? Where they are not, now you can't, while you observe the mixture, the components are not, you can't separate them from one another. Okay, you know that when you have the mixture, you can't separate the components from one another. Then children, the properties, you have to know what the properties and the composition is same. Okay, what do you have to understand? Properties and composition throughout the mixture is the same. That idea is different. Okay, when you have a taste from here, when you taste it from the above side, like the topmost part, and when you taste it from the lowest point, both looks the same, right? So then when you talk about the properties, what do you have to understand on the properties, children? Properties means the physical properties, what you can see or what you can taste or touch. So that is about physical properties, right? Physical properties are some like you have to know about color, transparency, density. Okay, so these are considered to be the physical properties, right? When you observe a homogeneous mixture, the color throughout the mixture is same. Okay, color throughout the mixture is same. Transparency throughout the mixture is same. Okay, you don't find a different color shade or over like in the lowest point and the different shade in the above point. You don't find something like that. Throughout the mixture, it is same and it is equal, right? Then the density, when you have the density, there is no density difference. Same density throughout the mixture. So what do you have to understand as the next point? When you want to study, when you want to confirm that is a homogeneous mixture, the properties and the composition of the mixture is identical. What I mean as the properties or the physical properties, children? The color, transparency, and the density is referred to as the physical properties. Okay. Transparency means it is like a color difference. Transparency, like transparent. Okay, how long it is visible from the other side. Like sometimes there can be a blurry view, like there's a different in color shades. Okay, so that is you call as a transparent. How long it is transparent. Okay, that not color difference, like you can call it as a transparent, the amount that is like how it is transparent, the level of transparency that you have throughout the mixture, right? So when you have the glass, like when you look it from the other side, how long it is visible to you. Okay, to the next side. So throughout the mixture, wherever you keep your eye and look, that will be the same. Okay, so that type of mixture you call as the homogeneous mixtures. Once again, let's revise it. Listen very carefully. Homogeneous mixture means what? First of all, you have to have an idea where the components of the mixture cannot be separated. Then, properties and composition throughout the mixture is same, or you call it as identical. Anyway is correct. Okay. What are the properties? What are the properties are identical? Color, transparency and density are identical throughout the mixture. Is that clear to you? Is that clear to you? Did you understand about homogeneous mixtures? Okay. How about the others? Everyone let me know in the chat, or you can unmute and tell. When you're sending chats, send it to the co-host. Right? Don't send it to the host at any moment, because if you send it, it will take some time to reply. Okay? And moreover, it will be like you will not get the answer for the question, because most of the time I don't see the co-host, the host chats. So make sure you send it to the co-host. Right? Good. Okay? So let me give you some more example on homogeneous mixtures, right? You can have a salt solution, right? Have you seen a salt solution, children? What do you call as the salt solution? Where you have the salt, which is combined with the water. That is a salt solution, right? That you call as what? A salt solution. What else? Can you guys, people give me some example for homogeneous mixtures? What else? Yeah, the ethyl alcohol we will be studying. Yeah, we will be studying in a while. Yeah, one mostly you have to remember 2 or 3. That is enough, right? One you can remember as salt solution, and the other one as the sugar solution. Right. Now let's learn the opposite of homogeneous mixture. Right. Before that, before we go to heterogeneous mixture, remember solution is another name for homogeneous mixture. Solution is another name for homogeneous mixture. Okay, solution is another name for homogeneous mixture. Note that down, that is important. Okay, not note it down in the sense, note it down in your brain. In the tube we will be right in a while. Okay, right. Now listen, let's study about the heterogeneous mixtures, right? Okay. Now children, let's have the solution. Like not the solution, let's have a mixture of clay and water. Have you all seen clay? Children, have you all seen clay in your life? Hopefully, yes. You people live on the earth and you guys have seen what is a clay. Okay? So it is not a new topic, right? Okay. So now children, when you have the mixture of clay and water. Okay. You find the mixture of clay and water. Right. Now, what you can observe while you are mixing, clay and water can be differentiated. Now imagine you have a clay and you have some water. You are mixing it to one beaker or one component. You are mixing as one mixture. Okay. Then you can observe, when you imagine, you can observe that you can come to an end by telling that where you can separate the component, right? When you observe, you can come to an idea, okay, I can separate this component, right? You can have a visual imagination, visual idea of where the lumps are formed above, water structure you find it below, or sometimes you find the lumps below and water you find it above. There is a color difference, there is a shade that is present. So you can identify those changes, right? You can identify those factors when you look into a heterogeneous mixture, right? The very first thing where you can separate or you can distinguish the components in the mixture. Then, as the same thing that we studied, you are going to classify based on the same criteria. Okay? One was the separation. In homogeneous mixture, you can't separate. Heterogeneous mixture, you can separate. Okay? Then, children, what you have to know next? As the next, properties and composition. Okay? When you want to know about the properties and the composition, children, that can be non-identical. Okay, you can differentiate them. They are different. Okay, when you look into the composition and the properties of the mixture, they are different, children. They are not the same. Okay, so what are the properties that you have to consider? What are the physical properties that you have to consider while you are looking into a mixture? Tell me, children, what are the physical properties that you have to uh, uh, understand or you have to know while you're dealing with a mixture? Tell me, what are the physical properties? We were studying like minutes ago. What is it? Come on, answers. You have to answer to the questions. Very good. Color, transparency, and density. Right, let's prove this. Now, when you want to know about color, okay, now let's take the clay to be as a dark brown, okay, a dark brown color, okay. You find certain lumps, the big particles are being settled below, and you find a dark brown shade below, okay. At the bottom of the container, you found a brown color in the bottom. Okay, now you know that in the above you find the water. Okay, you find a very light color, light shade of brown in the above. So now what you can understand, initially in the bottom you find a dark color, and while you are looking into upwards you find a light brown. You find different colors in the mixture where you can separate the colors, which means they are not identical. Right? In the mixture, the color, one of the physical property, which is color, is not identical. Right? So, that is one thing. Then the transparency. Now, when you observe through the bottom, now you are keeping your eyes, you are looking through your eyes from the bottom. Can you see the other side? Obviously, you can't. Obviously, you can't. Why? There is less transparency. Okay, there is less transparency. While when you come to above, there is a light brown shade of water, right? So when you observe through that, yeah, you can observe somewhat, but not in a clear visual. You can get a clear view to the other side, but somewhat you can observe. While you compare the transparency from the bottom part and the above part, the above part is having more transparency while the below part is having less transparency. You can't see, okay, from the bottom part. Okay, so there is a transparency difference as well. Then the density. Why do you identify lumps? Because they are high in density. Density is high. Okay, when you consider the clay, the density is more higher than the water. So therefore they go down, then the water remains up. So the density is not identical. They are not the same. So all the physical properties are not identical. They are not the same. They are not equal. Right? So when you find a mixture like that, you call it as the heterogeneous mixture. Did you understand what is heterogeneous mixture? Did you all understand? Okay. How about the others? Everyone let me know. Yeah, how do you define it? First, you talk about the separation. You can separate the components. Then you're going to tell the properties and the compositions are not same. They are different. You can distinguish, or you can it is not identical throughout the mixture. Okay, where the color, transparency, and the density is not same throughout the mixture. So when you explain in that way, that is heterogeneous mixture. So some other examples you can take oil plus water, right? Then wheat, flour plus water. So some examples. You can just have few, not necessary, but better to know. Okay, sometimes they do ask in your exams. Yeah, correct. Good. So understood about homogeneous mixture and the heterogeneous mixture. Is it clear to you all? Calcium oxide and water. Yeah, you can tell. No problem. That's correct. Okay. AI in the sense like you can't kind of like it is like you can't differentiate right now when you look at the atmosphere. Can you differentiate the oxygen and carbon dioxide? No. So both are colorless and they are odorless. So AI is not that suitable to tell, but it is made out of different components and you will not be able to find out by looking. Okay. So it's a kind of they are like physically they cannot be separated and they are kind of chemically combined as well. Sometimes they do react, no? So better to avoid air. You can tell anything else like the sea water and air that can be told as the homogeneous mixture. Okay, you can have the you can have that sort of idea, but don't tell it to the heterogeneous mixture because you can't directly separate the components in the air. Okay, so better not to tell. Right? Okay. So is it clear now? That's clear now. So let's move to the next. Right. Now we studied the classification among the mixture. Right? We studied the classification among the mixture. Right? So then let's move to the next topic. Right. 1 minute. Okay. Now, when you find a solution, right? Now, when you find a solution, what do you mean by a solution? It is a homogeneous mixture, right? What do you call as a solution? Homogeneous mixture, right? So, let me take a homogeneous mixture, right? Let's take this to be the homogeneous mixture that I'm talking about. Okay, let's take the salt solution, right? We are taking what solution? Salt solution, right? So in the salt solution, how many components can I find? How many components are present in the salt solution, children? Let me know. How many components do you find? Very good. How about the others? Everyone reply. Good. Okay. You find two components. What are the two components? One is the salt. The other one is the water. Okay. Now tell me, when you're randomly, you're just preparing, okay? Can you tell me which is in the less amount and which is higher? Which one is less? Which you find in a less amount, less quantity in the mixture, which you can find? Is it the salt or the water? Very good. It's the salt. So the less quantity, the less amount that is added to the solution is the salt, right? Which you find in a high amount, more amount which you find. Which one do you find? Yes, that is the water. Now, when you consider a solution, right? When you are considering a solution, the component or the substance that is present in less amount you call as the solute. Okay, that you call as what? The solute. What is a solute? The amount, the component that is present in less amount in the mixture you call as the solute. Okay, then when you find a component that is in high amount in the solution you call as the solvent. So what you have to understand overall, the component which is less in quantity, less in amount, that you call as a solute. Okay, you find one component which is high, that you call as the solvent. So did you understand the difference between the solute and the solvent? Is that clear? What is solvent and what is the solute? All okay? Good. Right? Okay. So that is one thing that you have to understand. That's just an idea that you have to have. What is a solute? Solute is the substance or the component that is less in quantity in a mixture or a solution. Then the solvent is the one which is high. Okay, in the mixture. Right? Okay. Now children, when you have a solution, let's study about the solubility of solute. Okay, the next topic is about the solubility of solute. Right. Now, when you want to know about solubility of solute, right? When you want to know about the solubility of solute, understand one thing. Okay, the amount, the quantity of the solution is fixed. Okay, the quantity of the solution is fixed, which means it is 100 gram. When you are like you are explaining what is solubility of solute, the solution amount, the quantity of the solution is fixed, which is 100 gram. Okay, now let's take the solution that you are mixing is the salt solution. We have for 100 gram. Now, you can have an idea like when you add 2 spoons of salt. Okay, you are adding how many spoons? 2 spoons of salt. It will dissolve. Okay, you are adding 2 spoons of salt to 100 gram of water. Then you are mixing. You are stirring well where the salt will dissolve. Right? In another instant, I am taking the same amount of solution, which is 100 gram, and I am adding around 20 spoons of salt. Then tell me children, when I am adding 20 spoons of salt, will it dissolve? Will you find a solution like you can't differentiate the components as the homogeneous mixture? Will you find something like that? When you add 20 spoons of sugar to 100 gram of water? Yes or no? Will you find it? No, you will not. You will find the difference. Like you will find the salt crystals where it is not dissolved, some are not dissolved, right? So that is mean now solubility means the maximum amount, right? You consider the maximum amount of solute that you can add to the solvent, like to the solvent of 100 gram where it will dissolve. Okay, listen very carefully. What do you have to know? The maximum amount of solute that you can add to 100 gram of solvent where it will dissolve at a certain temperature. You are not changing the temperature. Okay, now when you change the temperature, obviously that can dissolve. But you are not changing the temperature. It is in the room temperature. You initially test by adding 2 spoons of salt. What will happen to the water? It will dissolve. Okay, it will dissolve. But when you have 100 gram of solvent, but you add 20 spoons of salt, in that point it will not dissolve completely. Okay, incomplete dissolving take place, right? So what is solubility of solid? What do you have to understand? The maximum amount of solute that you can add to 100 gram of solvent where it can dissolve at a certain temperature. You are not changing the temperature, it is a constant. You are not changing the temperature. Initially it is 25, later you increase to 30. No, it is 25 throughout the experiment. It is 25 throughout the experiment. I'm just giving you a value. Okay, right? So that is how you explain what is solubility of solute. Once again, listen very carefully. Okay. So you are choosing, you're not choosing, like it is a point that you have to understand. This is a fixed value that you are adding. Okay. You are having, okay, I'll explain it. Listen, right? You are having 100 gram of solvent. Okay. Now you are having, let's assume that since you are preparing a salt solution, the solvent is what? Okay. Now, you are adding 2 spoons of salt. What will happen to the mixture? It will dissolve. Okay, the salt will dissolve. You will not be able to differentiate, or you will not be able to separate the components. Right? Salt and water is dissolved well. Okay, but when you have 100 gram of water, you are adding 20 spoons of salt. You are adding 20 spoons of salt. That point you can see an incomplete dissolving taking place. Some parts you find the crystals visible, some are dissolved. When you taste it, you find the salty taste. It is like halfway, partially it is dissolved, right? So you find it is not completely dissolved. It is not being a solution anymore. Okay, it is not being a solution anymore. It is becoming a heterogeneous mixture. Right? Solution means what? Where you can't differentiate the components. But when you have 100 gram of water, when you add 20 spoon to it, then it will turn into a heterogeneous mixture. The idea of solubility of solute is, children, where you can add the maximum solute. Okay? The maximum amount of solute that can be added to 100 gram of solvent, that where it is dissolving at a certain temperature. You are not changing the temperature. That should dissolve. The maximum, maybe the maximum amount of salt that you can add is 4 spoons only. Okay. After whatever the amount that you add after 4 spoons, that will not dissolve. Okay. The maximum point of adding, okay, maximum point of adding the solute is 4 spoon. Let's assume as that. Okay. So then that is what solubility is about. Solubility of solute is this. That solubility means what? Dissolving. The way that it can dissolve, the maximum amount, how much when you add, it will do the dissolving process completely. Now when you add 20 spoons, it will not dissolve completely. Okay. When you add 4 spoons, yes, it will dissolve. So the solubility of solute is 4 spoons. But you don't like do any calculations, but you have to know the definition. Okay, what is the definition? The maximum solute that can be added to 100 gram of solvent where it can dissolve at a certain temperature. Is that clear now? Is that clear? Everyone, let me know. Is it clear to you? How about the others? All okay? Everyone, can you all process what is on the board? Is it clear to you? Listen, solubility of solute is the maximum amount of solute that you can add to 100 gram of solvent where the solute can dissolve at a certain temperature. Right? You're not changing the temperature. You're adding little by little of solute, 200 gram of solvent. The maximum point where it can dissolve, okay, where it can completely dissolve is known as, like, that process is known as solubility of solvent. Are you okay now? Good. Right? So everyone is fine with it? You're most welcome. Right. Okay. So now, children, it is a time to do the work. Right? You're supposed to do some questions. The people who don't have the tute, you can send a message to my number, which I gave you a while ago. Just let me know if you people don't have the my number, then I can write it down here. All right. Individual classes are not done, okay, but we already have limited number of students, so I hope that when you join, you will be able to understand. Okay, individual attentions are always given. You can have a look. Right, so children, start doing the work. Right, what is a mixture? Homogeneous mixture, heterogeneous mixture. Give some examples and give the other name for a homogeneous mixture. Define what is solute and solvent and what is known as solubility of solute. Do all we will be discussing, right? And the people who were there for the last class, like who are supposed to do for the who are supposed to do the exam. I think only Zainab did the exam. How about the remaining students? Why you people did not attend the exam? Like the people who were there for the paid class? Jacob, did you attend the paper? Okay, so afterwards, didn't you have some free time to do it? Like it was just probably around 1 hour paper, right? So try to do it, Jacob, by today or by tomorrow and send me your answers. I had to correct it. Okay. Solute and solvent. Okay, solute means the component which is less in the mixture. Okay, solvent is the component which is high in the mixture. The composition is high in the mixture, right? So you can draw simple diagrams, you can draw and you can do whatever in the book, but make sure it is neat enough where you can study later. That is important. Let me check whether have you all sent any messages regarding the tute. So the part 1 tute is here. Part 2 tute will be sent soon to the group. One minute, children. I'll share it. The people who send me a message. What's a mixture? What is it? Mixture is a matter, right? Where two or more components are present, which is not chemically combined but physically separate, which can be physically separate. Please don't refer any sort of resources like the textbook or anything, children. I want you to write it all alone, right? That is where the learning process is completed. Okay, I want you to do it alone. Don't refer to books. It is like you're spoiling yourself. You're like fooling. In other words, don't do that. Okay, if you have any doubts, ask the teacher wherever you go. Wherever you go, just make sure you're not fooling yourself by copywriting. Don't copyright. You can refer, study, close the book, and do the work. Okay? Don't just open the book and just keep on writing what is on the book. It's not use. Okay, it's not a useful way of study. Don't do that. At any point, any doubts, you can ask your teacher or wherever you go. As the guidance, you can get it. Yeah, next week, Saturday morning, we will be doing the part 2 session. Sure. We will be having that. Yeah, probably children. I created the lesson plan. I think I did not send it. I will be sending it in a while, like once the class is over. I prepare the lesson plan like weekly, what we will be doing. Until December, we have taken that. By October, if I'm not mistaken, let me check. I was like supposed to tell for the grade 10, but I forgot in the last class. Okay. By October and November, we will be completing the syllabus by the November second week or third week, because we will be starting the biosphere lesson from October, and we will be completing it by November third week, like 6 to 7 weeks of class will be taken for only biosphere lesson. Okay, because it is a long one, so I want more time to discuss on that particular lesson, so we will be taking that time. The remaining lessons will be covered by the fourth week of September. Okay, by fourth week of September, we will be completing until hydrocarbons. Then the biosphere lesson will be remaining. We will be doing from October till November third week, probably, because December, probably first week, we will be having your exams, right? Like 8th means like it is almost the very first week. So we can't have the most extended days now. So we have to complete it earlier. That is the time period allocated for the past paper practice as well. By the end of November, you are good to go to the exam. So that is the target. We'll see how it works. Do all the questions by yourself, and once you are done, let me know. We can have a quick discussion and move to the next. Solute is a component which is less in amount in a mixture. In a solution, probably. Are you all done, students? Good. Most of you all are done. Good job. How about the others? Do you all need more time or have you all completed? Good. So I think we can have a discussion, right? Okay. So what is a mixture? What is a mixture? Just check your answers whether it's correct or wrong. I'll just say, just try to check. Okay. So mixture is a matter where there is two or more components present. It is not chemically combined but can be separated using physical methods, or physically it can be separated. Anyways, is correct. Okay. Homogeneous mixtures means where the components of the mixture is cannot be separated while observing, and the properties, physical properties and compositions are identical throughout the mixture. What are the physical properties? You can mention it on the side or somewhere just about the physical properties. Color, density, transparency are the physical properties that it's supposed to be look into while you're observing a mixture, right? Heterogeneous mixtures are the mixtures where components of the mixture can be separated, can be distinguished. Anyways, correct. And the properties and the compositions are not identical, they are different. Okay, where the color, transparency and density is different. So examples you can tell for homogeneous salt solution, sugar solution, ethyl alcohol plus water. So that way is correct. Ethyl alcohol and water I'll explain for detailed in a while, then you will understand why that comes under homogeneous, right? Heterogeneous, you can have salads or whatever, like the cement and water, clay and water. Then you can have you can't mention as solutions, children. Don't use the word solution for heterogeneous mixtures, right? Then yeah, that's it. So you can have anything else. If you have written any other answers except for this, let me know. If you want to check whether it is correct or wrong, let me know, right? So what is the other name for homogeneous mixture? That is solution, right? So define solute and solvent. What do you call as the solute? Solute is the component that you find less amount in the mixture, or like moreover it is the solution. Okay. Solvent is the component that you find high amount in the solution. Solubility of solute is the maximum amount of solute that can be added to 100 gram of solvent where it can dissolve at a certain temperature. Right? Did you all write all of these? Do you have any doubts to clarify? If so, let me know. Any doubts? Good. So if you have any doubts, send it in the chat. I'll let you know. Yeah, I can check. You can send me in WhatsApp. I'll check. If you have any confusion on your answer, like whether it is correct or wrong, okay, you can send me in WhatsApp. I'll check. Okay, send it to my number, but not now. While I'm discussing, once I finish the discussion of a particular part, I'll give you the work to do. Then at that time, you can I'll check and let you know. But send it now. Then only I will check. Okay, right. Okay, now you know what is solubility of solute. No, now there can be certain factors. Okay, solubility of solute can be affected by certain factors, right? Normally that is three. Okay, the factors are three. Solubility of solute. Okay, solubility of solute means where you have a 100 gram of solvent. Okay, listen, 100 gram of solvent is present. You are adding an amount of solute. No, you are adding an amount of solute, right? The maximum amount that you are adding, okay, the maximum amount that you add is is defined where it can dissolve. Now imagine you have 100 gram of water, you are adding around 40 gram of salt, okay, where the entire amount of 40 gram is dissolved, okay. Then when you add 50 gram of solvent, it is not dissolving completely, which means 40 gram is the maximum amount that you can add to the solution, to the solvent, right? So that you call as the solubility of salt, the maximum amount of solute that you can add to 100 gram of solvent, right? Where it will dissolve completely at a certain temperature. You are not changing the temperature, but you are adding the maximum. Okay, the maximum amount is described as the solubility of solvent, solubility of solute. Got it? Did you understand that? All okay? All right. So others listen. Okay, listen here very carefully. Right. Now, when you study about the solubility of solute, what do you have to know, children? Solubility of solute depends on certain factors. There are some factors where solubility of solute depends. There are three. Okay. One is the temperature. One is the temperature. Second one is the nature of the solute. Nature of the solute. Then the third one is the nature of the solvent. Right. So let me explain you. Listen very carefully. Right. Now let's prove that temperature is a factor affecting the solubility of the solvent. Okay. Listen. Right. Now let me take two test tubes. Right. Let me have two test tubes. Okay. I have taken two test tubes. Right. So when you are choosing a factor, okay, now let's imagine that we are choosing, we are doing an experiment to prove that temperature is a factor affecting the solubility. Then children, when you are adding the temperature to the test tubes, that should be different. You can't add the same. Okay, you will not find the results. The remaining ones should be the same. Now, when you find a solution, you find two components, right? One is the solute, one is the solvent. So, let's take the solute as the sugar. Okay, the component that we are adding is the sugar. Right. Then, let's take the solvent as the water. In both of the container, both of the test tube, we are taking the same solute and solvent. But here I am changing the temperature. 25 degrees Celsius, 50 degrees Celsius, right? So what do you have to understand? When any one of these factor is increased, like normally the temperature, when the temperature increases, the solubility of solute will increase. That means they will dissolve faster. When the temperature is high, they will dissolve faster. That is the idea. Okay, that is the idea. So, tell me children, in which of these two test tubes the solubility of solute is high? Is it in the A test tube or the B test tube? In which one? In which one? Very good. In the B test tube. Why? Why is that? Ask a question. Why? To yourself. Ask it. Ask a question as why it is like that. Because you can identify the different temperature between the two test tubes. Okay? Because of the two different test tubes. The temperature is high. Then what is going to happen? When the temperature is high, the kinetic energy is like fast. Like they move, the vibration of the particles are high. So they will undergo a dissolving process is faster. The dissolving process will take soon as possible than the A tube, A test tube. Is that clear? So listen the next one. Okay, that is what you are supposed to prove for the temperature, right? Now, when you want to prove for the nature of solute, okay, now we are going to prove the nature of solute. To do that work, you have to know about polarization, right? The polar compounds, right? So polar compounds means, children, due to electronegativity, you might have learnt in your grade 10 about polarity. Okay, polarity, you might have learnt it in the grade 10 syllabus. But then let me give you a small idea of what is it, right? So if a compound that have undergone polarization, okay, if they have undergone polarization, that type of compound you call as the polar compound. Okay. So what is polarization? Where there is where there is electronegativity difference throughout the mixture. Okay. One is partially positive, one is partially negative. Hopefully you have an idea of polarization. Okay. Right? So when a compound has undergone the polarization, that compound you call as the polar compound. If they have not undergone polarization, right? They have not undergone polarization. So those compound you call as the non-polar compound. Non-polar compound. So those compound you call as what? Non-polar compound. Right. Now children, the best way to remember this, according to me, to make your work easy. Remember, for polar compound, water. Remember the example, water for the polar compound. Okay. Whatever the substance that you add to water, if they dissolve in water, that is a polar compound. Now, for example, let's take the test tube. Okay. You have water. Okay. You add sugar. What happened to the sugar? Did they dissolve in water? Did they dissolve in water? Yes or no? Will they dissolve or not? Children, hopefully you all are not sleepy since it is a Saturday. Okay? Come on, give your answers. You add sugar to water. Will they dissolve? Yes. Okay. Right? They will dissolve. So when they are dissolving, you know that water is a polar compound. As I told you, are supposed to remember polar compound example as water. If you want to identify whether sugar is a polar compound or not, what are you supposed to do? You add sugar to water. If they dissolve, that is a polar compound. So sugar is a polar compound. Okay, sugar is a polar compound. So on the other hand, if I take in this B test tube, I'm having the solvent as the kerosene oil. Right? Let me take the kerosene oil to the B test tube as the solvent. Okay, I am adding sugar. Think and tell me, will sugar at once dissolve in kerosene when you don't change the temperature? At a certain temperature, what will be the solubility? Will there be any solubility happening or taking place? Yes or no? Yes? No, no, it is not. Okay, there will be no solubility taking place when you don't change the temperature. When there is a certain temperature, so you consider if they don't dissolve, a factor that they do not dissolve. Let's take the kerosene oil as the non-polar compound. When they don't dissolve in non-polar compound, that is a polar. So what do you have to understand? If it is a polar compound will dissolve in a polar compound, while the non-polar compound will dissolve only in non-polar compound. Now, in case if you are adding oil, okay, you are adding oil, or let's take the petrol. Kerosene and petrol can be some, like, most of the time it is like mixed, right? Let's take the petrol. Now tell me, will petrol dissolve in kerosene? Will they mix together? Yes, very good. So what you have to understand? Kerosene is a polar compound. Then petrol is also polar compound. That is why they dissolved. When you add sugar to kerosene, they did not dissolve. Why? Because kerosene is a non-polar, while the sugar is a polar. Okay? Did you understand what is the difference between the polar compound and non-polar compound? Did you understand the idea of what is polar compound and non-polar compound? Okay, listen. Polarization means where they have a electronegativity difference. What do you mean by electronegativity? Where there is a where there is a ability to attract an electron, that you call as electronegativity, right? So when you have a compound, now when you observe a compound is made out of atoms, or you simply call as ions, right? So how do they get the ion? So when they have a partial charge, when they attract more electron, they will become negative. If they remove electron, they will become positive, right? So when there is a charge as positive and negative in a compound, that is where they have undergone polarization, right? So whatever the compound that they have undergone polarization, you call as the polar compound. While on the other hand, if they have not undergone the process polarization, you call as the non-polar compound. Simple way to remember, to understand how this connection works. Remember water as one example for polar compound, right? Whatever the substance that you add, and if that substance dissolve in water, then you have to know that that is a polar compound. Now water you have, when you add sugar, that will dissolve. Polar and polar dissolving take place. When you have kerosene oil and sugar, this is a non-polar, while this is a polar, no dissolving taking place. Okay? How to find whether it is a polar or non-polar? That is what I told you. Simple way. You don't have much detailed idea to study under this. Remember, polar compound means water. You add a substance to water. If they dissolve, that is a polar. If they don't dissolve, that is a non-polar. Now, when you add water and kerosene oil, will kerosene oil dissolve in water? No, they will float. You can differentiate, which means this is a non-polar. Okay, this is a non-polar. So think water, whatever the substance that they give you, try to add it. Imagine that you are adding it. What will happen when you add oil to water? It will not dissolve. Then oil is a non-polar. Okay, if they are dissolving in water, they are polar. Got it? Is that clear? Good. Right. Okay. So, when you want to study the nature of solute, right? To study about the nature of solute, you have to know about polarization. Okay, that is what I taught you what is polarization, right? So, what you are supposed to do is, as I told you children, when you take two test tubes, the factor that you are proving that is necessary, or it is the factor that is affecting, only that factor should be different. Which means when you have the A and the B, the solvent that you add should be the same. When you are proving the nature of solute is affecting. Is a factor that is affecting. Okay. So then what are you supposed to do? When you are proving that nature of the solute is the factor, one of the factor affecting the solubility, the remaining ones should be the same. Which means the solvent should be same. Let's take it as water. Okay, right? Then the temperature 25 degrees Celsius, 25 degrees Celsius. But what I am doing here, I am changing the solute, right? Let me have sugar here. Let me have oil here. Right. Now tell me what is going to happen. You know what is going to happen, right? You have to think about the polarization. Water, polar compound. If anything is dissolving in water, that is also polar compound. The dissolving, the solubility will take place. Okay, solubility of solute will take place. If there is is non-polar and polar, there will be no solubility taking place. That is the idea, right? So think once again. Tell me now, will A test tube undergo solubility of solute or B test tube will undergo? Which one will undergo polarization, which is one factor where the solubility of solute is high? In which test tube, A or B? Very good. It is the A. Good job. Everyone got it. Right? So why is that? What is the idea? You have to know that when you have a polar compound, that will dissolve in a polar compound. When you have a non-polar compound, the non-polar compound will dissolve in non-polar compound. Got the idea? Is that clear? Non-polar to non-polar. Very important talk. Okay, very important talk to remember. Clear? Got it? Yeah. Oil is non-polar. Why is that? Because when you add oil to water, it will not dissolve. So you consider oil to be non-polar. That is why I told you to remember for polar compound, remember water. So whatever it is dissolving in water, that is polar. Whatever do not dissolve, they are considered to be non-polar. Okay? Good. Right? Now let's prove the nature of solvent. Okay, now when you are proving the nature of solvent, what should be changed, children? What should be changed? The solvent in the both of the both the test tube should be different. Okay, right? Listen, look here. A test tube, B test tube. Temperature same in the both. Right? Let me have the same solvent as sugar. So all this time we were talking about sugar. So let's take that sugar. Right? But here I am changing the solvent. Let me have water here. And on the other hand, let me have the petrol. Right. Now think about, you are supposed to give me the answer. Okay? Think about the solubility. Think about the polarization, polar compound, non-polar compound concept, and tell me in which of the following test tube the solubility of solute is high. Everyone, let me know in the chat. Everyone. Good job. Others? Jacob, Zainab, answers please. Good job. Right. So you are well practiced to the idea, right? You know that water is considered to be a polar. You are adding sugar, that is also will dissolve. Then there is a polar and polar. So polar and polar dissolving taking place. Okay. You have petrol. It is a non-polar, while sugar is a polar, right? Then polar and non-polar will not dissolve. Therefore, solubility of solid will not take place. Dissolving process is not taking place, right? So, A test tube will have the solubility. Is that clear? Yeah, A is the answer. Got it? Good. Right? Okay. Take out the textbook, not textbook, tube, and start doing the work. Draw the diagrams as I drew, okay, and state your observation. Okay, I think the space, will that be now? Oh, I have left a space. So here why I have left space is, children, to draw the diagrams, the test tubes, to differentiate, okay. So draw that and send me pictures of your work. I'll correct it. Okay. I want you to attempt it by yourself as a way you differentiate it. Do it by yourself and send me pictures of your work. So I'll correct it. Do that soon. We have a lot to discuss more. Draw all three. Draw the very first diagram to show that the temperature is different. Okay, temperature is a factor affecting. How do you do that? You make all the other same. Solute should be same throughout the both the test tube. Solvent should be the same. You change the temperature. 25 to 35. Just differentiate with the temperature. Then what are I supposed to tell? Which test tube has the maximum heat supply? When there is a high temperature, the solubility of solute is high. Okay, that is your idea that you have to remember. So similarly, you have to draw first nature of solvent and nature of solvent. Do it by yourself. Draw neatly. I don't want freehand sketch. Okay, children? Use rulers. Make sure your workings are neat. Okay, where your examiner or the paper marker is able to read your answer. So practice from now itself. This is the time to do that. Okay, don't do it in the last moment. Nothing will be changing. Okay, so learn from the beginning how to do it. So you don't have any rush at the last moment. Now itself work slowly. Do it and send me in WhatsApp. Let me give my number. So this is a number. You can send your work to this number. I will figure it. As usual, what happens in the theory class. Do it by yourself. You can write short notes. You can do whatever you want. Are you done with the work, children? Done? Can we have the discussion? Send your answers. I'm waiting until you people send to check. Send your answers soon, children, to check whether have you written correct, because I will not be discussing this part. As I was explaining, since we have just 5 more minutes, I have to discuss about the solubility of solute as solubility of gas as well. Okay, if you have sent, I'll check. Okay, I'll check. Others, send your answers soon. Okay. So let's continue with the work. So you are supposed to send me, children, everyone. Okay. So I'll be waiting for your answers. Send it. Right. And children, you can do certain questions that you have here as well. For polar compounds and non-polar, in the next page you have certain questions. You can do that as well. Okay? Right. So listen very carefully now. Okay. So now we studied what is the solubility. What are the factors affecting the solubility of solute, right? So now we are going to study the factors that is affecting the solubility of gas. Okay, the factors that is affecting the solubility of gas. So there is only two factors, children. You are not that's not that necessary. Like you don't need much idea. Just when you know the two factors, that is enough. Okay. First one is the temperature. When the temperature rises, the solubility of gas will also increase. That is one factor. Okay. The second factor is pressure. When you exert the pressure on the gas, the solubility of gas will increase, which means when any one of these factor increases, the solubility will increase. Right? The solubility will increase. That is the idea that you have to know over here. Is that clear? Did you understand about solubility of gas? Just a very simple idea that you have to know. That is, solubility of gas means where the temperature and the pressure are the two factors that is affecting the factors that is affecting the solubility of gas. Is that clear? Let me know soon, children. Yeah. right? So now when you talk about the solubility of gas means what? Where the gas is being dissolving in a way, like you can tell like that when you take a soda drink, okay, you know that the carbon dioxide is highly with a pressure, it is sent into the bottle. So that is why when you open, they pop up, right? So that is where the solubility, the gas is being soluble, like it is being like dissolving way into the mixture or to the water, okay, where you send it through a high pressure. So when you send it through a high pressure, the solubility of gas is high. So that is what you have to understand. When there is a high temperature or a high pressure, the solubility of gas is high. Okay, so that is a point that you have to understand. Is that clear? Okay, right? So where you have the one example is that soda bottle, right? When you have the soda bottle, when you observe it, you find certain gas, right? That is what carbon dioxide is sent with a high pressure into the bottle. So that is why when you open, that pop-ups. Okay, right. So that is one thing that you have to understand. And a small point that I missed from the earlier part, that is the question uh, 8 and 9. Okay, let me give you an idea of what is it. Right, then all together you can do the work. Okay, right. Now, I started with the polar compounds and non-polar. Before that, children, due to polarity, you can classify the compounds into organic compounds and inorganic compounds, right? So, you might have studied in your grade 10. Okay, so organic compounds mean what? Where they have the presence of carbon. Carbon element is present in their elemental composition, right? And inorganics means where there is no presence of carbon. Have the presence of carbon, absence of carbon element, right? So now this can be further divided into two categories as organic polar compounds and organic non-polar compounds. Organic polar compounds and organic non-polar compound, right? Similarly, this inorganic can be classified into two as inorganic polar compound, inorganic non-polar compound, right? Okay. So now you have to remember certain examples under this, right? So when you want to know about the organic polar, okay, where they have the carbon and they have undergone a certain polarization, right? One is alcohol, okay, one is alcohol. You can remember alcohol. Formalin, have you heard about formalin, children? Do you have any idea about formalin? No? So formalin is the one where they add if they don't want the decomposition process to take place. Now normally when they do the post-mortem or the autopsy, they do, children, like when a person dies, they have a dead body. So when they want to preserve the body, they inject formalin. They take off all the organs present inside the body. They apply or they inject or they add formalin. So formalin is one of the it's a kind of a chemical where it will prevent the decomposition. Okay, the decomposition process will be delayed, right? So that is one example. Then acetone is also another. Acetone is not necessary. You can remember alcohol and formalin. That is it. Okay. Then what you have to know the next is the organic non-polar. Okay, they are organic compound. They have the presence of carbon, but they have not undergone polarization. That's the idea. Okay. Benzene is one. Then you can remember carbon tetrachloride. That is important for the next topic. where we learned about the separation techniques. Under that, you have a small part of the under solvent extraction. You have to study, like you have to know about carbon tetrachloride. So let's take that as one of the example. Okay, so when you talk about the inorganic polar compound, you have to take water, right? You can take water, then you can take ammonia, NH3, ammonia, not NH4, NH3. Then hydrogen chloride, okay? Hydrogen chloride is also one of the inorganic polar compound. These are necessary, children, okay? Then inorganic non-polar compounds. You can have carbon dioxide, okay? Carbon dioxide can be present, carbon dioxide. So you know, right, carbon dioxide, why do you have carbon dioxide and the inorganics, children? You can find carbon in carbon dioxide, and even though having the presence of carbon, why do they come under inorganics? Because they have more likely features of inorganics, right? When you observe the features, they don't have the features of organic compound, they do have the features of inorganic. So that is why they are considered to be the inorganic compound. Okay, even though they have the presence of carbon. That's an exception. Carbon dioxide, carbon monoxide, bicarbonate all comes under that category, right? So that is carbon dioxide and carbon disulfide. Okay, carbon, this is supposed to be in the liquid form. Okay, carbon disulfide. Okay, so these are the ones that you have to remember. So let's go through once again. Listen here. Okay, so when you talk about chemical compounds, based on the presence of carbon, compounds are divided into two major categories as organic compounds and inorganic compounds, right? So what do you mean by organic compounds? Organic compounds has the presence of carbon, okay? While the inorganic compounds do not have the presence of carbon. In their elemental composition, they do not have carbon, okay? Right. So organic compounds further classified into two major categories due to polarization. Okay, if they have undergone polarization, you call it as the organic polar compound, and if they don't undergo polarization, you call it as the organic non-polar compound. So under that you have some examples. Under organic polar compound, you can remember alcohol formula is important. You don't have to remember about acetone, not necessary. Okay, you can remember alcohol formally, that is enough, right? So when you want to know about the non-polar, where they don't undergo polarization, right? So that is benzene, carbon tetrachloride. Benzene and carbon tetrachloride, you can remember those two, right? So when you talk about the inorganics, further inorganics are divided into two based on the polarization. If they have undergone polarization, they are known as inorganic polar compound, okay, which is water, ammonia, hydrogen chloride. Hydrogen chloride is one, okay. Then the next one is the where the inorganic compounds have do not undergone polarization, which is you call it as a inorganic non-polar compounds, right? So they are carbon dioxide in the liquid form and carbon disulfide. Is that clear? Is that clear? You are supposed to memorize this. Okay, memorize in the sense, yeah, you don't have much understanding on the elements or the chemicals, but necessary to remember the terms, right? If you remember the terms itself, that is enough. Okay, nothing else is needed. Okay, so write down this as well, please. Do the work and then you can leave once we discuss the work. Do it first. Let me tell you what are the questions that you are supposed to do. Do question, we did not do question number 7, right? 9. Okay. Now here you can have ethanol is one of the alcohol, children. Ethanol and water. This is a polar. This is also a polar. What will be the observation? What will be the observation? Dissolving will take place, right? So then what you are supposed to conclude it? How do you conclude it? That is for your homework. We will be discussing in the next class the homework, right? Conclude it as ethanol is a polar compound, water is a polar compound, therefore solubility will take place, right? So what is observation? Dissolving. You see the dissolving taking place, okay? So do that. That is for your homework. 10th question is for your homework. Either you can send me your answers to check or else we can do it in the next class. Remind me when we start the next week class to discuss the work. Okay, if not, sometimes I might forget it. And the 11th question as well. So next week we will be starting the calculation. I thought of doing it today, but we don't have much time to do that. No problem. We'll do it in class. So do this work first. Do all from 7 to 11. Do it and then let me know. Everyone must do the work before you leave. 10th question you can skip for now. You can do it as your homework once the session is over. The people who sent me the work, I will be checking your answers once the class is over. What is the difference between polar compounds and non-polar compounds? Polar compounds means where they have undergone polarization, right? Non-polar where they have not undergone polarization. Okay? Do the work, everyone. Ahmad, Anat, when did you join the class, child? Did you join the class late? Done, students? Do it. So observation for grease and kerosene oil. Okay. So grease is a non-polar, while the kerosene oil is also non-polar. So non-polar and non-polar dissolve. Okay. That's your homework. You can do it later. You're welcome. Okay. So you people are done. So let's have a quick recap. Okay. Right. So what is the difference between polar and non-polar compound, right? So polar compounds are the compounds where they have undergone polarization. Okay. While non-polar compounds are the compounds where they have not undergone polarization. Okay. State few organic polar compounds and organic non-polar, right? Organic polar compounds, you can take alcohol, formalin. Okay. Non-polar compounds are benzene, carbon tetrachloride. You can take that. Okay. State few examples for inorganic polar compounds and non-polar compounds. Okay. Inorganic polar compounds are water, ammonia, then hydrogen chloride. Any two you can just state. Okay. Then non-polar compounds, you can take it as the liquid carbon dioxide and carbon disulfide. You can take that. Right? So this is your homework, the 10th question. We will be discussing in the next class. Okay. So the 11th one, what are the factors? Okay, it's a small typing error. What are the factors? Two factors are there. Okay, what are the factors affecting the solubility of gas? That is pressure and temperature. Is that clear? Any doubts on today's lesson? Do you have any doubts to clarify on today's lesson? Next week, probably we will be continuing with the calculation and the separation techniques, right? So, is this clear to you, children, what you learned today? Any doubts? You're welcome. Okay. So, since you don't have any doubts, then that's all for the day, students. We'll meet in the next class. Until that, take care. Bye.